sync.Cond in Go, a detailed explanation. In Go, sync.Cond is a powerful synchronization primitive designed to manage the coordination of multiple goroutines. It allows goroutines to pause and wait for certain conditions to be met before continuing their execution. Once the condition is satisfied, other goroutines can signal the waiting goroutines to proceed. This mechanism provides an efficient way to handle scenarios requiring precise coordination, such as managing shared resources or synchronizing stages in a workflow. Key methods. The wait method allows a goroutine to suspend its execution until a specific condition is signaled. When wait is called, it releases the associated lock, e.g. a sync.Mutex, temporarily, allowing other goroutines to access the critical section or shared state. Pauses the goroutine until another goroutine signals the condition. Automatically reacquires the lock when the condition is met, and execution resumes. Example use case. A consumer in a producer-consumer setup might call wait if the buffer is empty, pausing its execution until the producer signals the availability of new data. 2. Signal. The signal method wakes up one specific goroutine waiting on the condition. This is especially useful in scenarios where only a single goroutine can proceed at a time. Example use case. When one task finishes processing, Signal can notify a waiting goroutine to proceed. 3. Broadcast. The broadcast method notifies all goroutines waiting on the condition. It's used when a state change affects multiple goroutines, allowing them all to resume execution. Example use case. After a shared resource becomes available, all waiting goroutines can be notified simultaneously using broadcast. Dependencies. Sync.Cond requires an underlying lock, typically a sync.Mutex or sync.Mutex. This lock ensures that all access to shared state is thread-safe, preventing race conditions and ensuring consistency. Why is a lock needed? Without a lock, multiple goroutines could modify or access shared resources concurrently, leading to undefined behavior or corruption of shared data. The lock guards against these risks by allowing only one goroutine to modify the shared state at any time. Use cases. 1. Producer-consumer problem. Producers generate data while consumers process it. Sync.Cond enables producers to wait if the buffer is full and consumers to pause if the buffer is empty. 2. Resource coordination manages access to limited shared resources by ensuring only a certain number of goroutines can access the resource simultaneously. 3. Barrier synchronization. Multiple goroutines pause at a synchronization point and resume together when a condition is met. 4. Pipeline coordination synchronizes different stages of a processing pipeline, ensuring smooth data flow and preventing bottlenecks. Best practices. Guard shared state. Always pair sync.Cond with a lock like sync.Mutex to protect the shared state, ensuring data integrity. Use loops for waiting. When calling wait, always check the condition inside a loop. This prevents issues caused by spurious wakeups, e.g. a goroutine resumes execution without the condition being fully met. Signal appropriately. Use Signal to wake up only one goroutine when appropriate, and use Broadcast only when all waiting goroutines should resume execution. Minimize shared state access. Keep the shared state simple and avoid excessive locking to maintain performance. Advantages. 1. Simplifies synchronization. Sync.Cond abstracts away much of the complexity involved in coordinating goroutines, making the code easier to manage and understand. 2. Avoids busy waiting. Instead of continuously checking a condition, which wastes CPU cycles, sync.Cond suspends goroutines efficiently until they're notified to proceed. 3. Thread-safe coordination. When used with a lock, sync.Cond ensures safe access to shared state, preventing race conditions and data corruption. Conclusion. The sync.Cond primitive is an essential part of Go's concurrency model. It excels in scenarios where precise coordination of goroutines is required, such as managing shared resources, implementing producer-consumer workflows, or synchronizing pipeline stages. By allowing goroutines to wait for condition changes and resume execution in an efficient thread-safe manner, sync.Cond enhances the performance, scalability, and reliability of concurrent Go applications. Whether you are working with complex synchronization patterns or optimizing resource utilization, sync.Cond provides a robust foundation for building well-coordinated, high-performance systems.